Okay, so here is the tutorial over the concepts that people generally find difficult, get confused a lot, things like that they run into on the multiple choice. So I put four up here that we'll kind of talk about. These four concepts, deal with probably um, anywhere from 10 to possibly even 20 different questions on the multiple choice. So, a pretty significant portion. So, if we take a look at number one, is there is no difference between constant velocity and at rest. So, just because something is not accelerating or has balanced forces acting on it doesn't mean it has to be at rest. It can be moving. Now, what you have to keep in mind is that any balanced forces result in constant velocity. And my daughter's trying to help as well as we're going here. But any balanced forces will result in constant velocity. It doesn't matter what the motion was prior. Doesn't matter what the motion was after. As soon as the forces are balanced, it's at constant velocity. And it might be accelerating up until that point. So if it is accelerating up until that point, then whatever velocity it was at when it stops accelerating is the constant velocity it will continue to have. Now, the reason it has that continued velocity, even if it's going up, like against gravity or something like that, is because of the second issue, which is the law of inertia. And the law of inertia states that objects at rest stay at rest and objects in motion stay in motion unless acted on by an outside force. So there are lots of applications here as to why this can be a little bit confusing. So, for example, one that doesn't make sense to a lot of people is like a crane lifting something off of the ground. They think that the crane has to pull harder than gravity. It does not. As long as the object is moving upward, the inertia of the object wants it to continue to move upward. So all the crane has to do is supply the supply enough force to balance gravity. If that's the case, it will move at constant velocity, just like we said in number one. Now, we get down to Newton's third law. There on our third topic here. There's two things that you need to realize here. One, forces act on opposite objects. Now, Newton's third law, of course, is for every action, there's an equal and opposite reaction. And this, of course, we've paraphrased it by saying every force would have a partner that's equal in size and opposite in direction. So the one thing that you got to keep in mind here is that they act on opposite objects. So if object A is acting on object B, then that means object B is acting on object A. All right. And so what you'll see when you're naming these is it would be force of A on B is the partner force is force of B on A. All right. Also, when you run into the situation, like, for instance, when I was talking about why can't I pull my chair, because as hard as I pull on my chair, the chair will pull back on me. How then am I able to actually move the chair? When we run into this logic trap, like I said, it's a logic trap. It's not a reason trap. Don't use logic, use reason. We run into this issue here. The answer is the forces act on separate objects. They don't cancel because they're not balanced forces or balanced forces. So this is not a situation where we're talking about like up in number one. We're talking about an object that has one force acting on it. A different object has a different force acting on it. Yes, they're partner forces, but that does not mean that one can't accelerate or the other one won't, or that they can accelerate differently. Okay, so understand that. Next is free fall. Now, in free fall, I've got three things down there. One is the velocity. So as something is in free fall, does the velocity change? The answer is yes, yes, it does. It accelerates towards the Earth. So the speed that it's going, and velocity is just speed with direction, is increasing. The speed will stay the same because it's going towards the center of the Earth. So the velocity is increasing every second during a free fall event. However, the acceleration is not. The acceleration is constant. So even if I throw these tricky questions like I shoot a gun down and drop a bullet at the same instant, they would have the same acceleration. They would not have the same velocity, but they would have the same acceleration because they're in free fall. Now, the other thing to keep in mind is if you draw a free body diagram for a heavy object and a light object and calculate the acceleration of that object for an object in free fall, it's the same. Heavy objects and light objects fall at the same rate. The only reason that we in real life don't think this is true is because we have air resistance, and air resistance affects light objects more than it affects heavy objects. However, in a vacuum where there is no air, the acceleration is the same. So if you drop a penny and a feather from the same height, they will hit the ground at the same time. Now, the last thing I have down there is the weight. Now, this is the gravitational force. Now, remember, weight is the force of gravity acting on you, which is not the acceleration of gravity. The difference is that weight is the force of gravity times, weight is the force of gravity, which is the mass times the acceleration of gravity. Now, remember, if you were to change your location in the universe, your mass would not change, your weight could change. All right, this concludes the concepts tutorial. Good luck on the test.